All right, guys, so a lot of questions have been coming up on the forums I'm involved in. A lot of new people getting involved into the Land Cruiser LS swap about wiring, right? It's one of the most difficult parts. A lot of people are unfamiliar with it, and it can seem overwhelming at times. So what I did was I just laid out everything that I did to get to where I'm at that you see in the other videos with the engine running and everything. So I'm going to rewind. I'm going to make two videos here. This is just going to be kind of like a schematic overview with like the theory and how I connected things, and then I'll do a second part of like where those connectors and wires are physically at in the vehicle to kind of give you then a conceptual idea of where you need to gain access to. There's really only about one spot you need to gain access to, and that's behind the glove box in the dash, and then the fuse box in the engine bay, and that's really it. Not a lot of wires you got to go hunting and digging for. It's pretty surprising. So just rewinding, starting from that, let's talk about the LS motor you got. Unfortunately, everything I say, it's not cookie cutter. There's a lot of different models: Gen 3, Gen 4, LS, Vortec, LT, LQ4, LQ9. There's a lot of different motors and options out there. Drive-by-wire, drive-by-cable. I'll just give you my experience, which I think is, if it's kind of your first time, I think this is kind of the easiest way to go. It's gonna be a Gen 3 motor, drive-by-cable. It's gonna be the easiest way to go, and I'll show you how I did that. So how I got my motor was through a junkyard pull. Pulled out the motor, transmission, take the entire wire harness with you. As a driveway engineer says on his YouTube channels, take everything. You can then manipulate that harness yourself by thinning it out, taking out the wires, stuff that you don't need, or you can leave it all as is and then hook up the power that you need to make it work, and I'll cover that here in a second. So how do you know what you need out of your GM LS, for a generic lack of term, harness? Well, it's not that I came up with this. You need to go to lt1swap.com and you need to download his instructions and watch his instructional videos, which can be like an hour long, wire by wire, connector by connector, with amazing instructions and diagrams and exactly what wire and everything to cut out and every label and everything that you need. You'll follow along. So you go to his website, you find out what you need. You got a Gen 3 harness modification for a standalone, which in all intents and purposes is what we're doing. You're making a standalone GM engine in the Toyota. So it's kind of a standalone process. You'll print out, there's two connectors, hopefully you're familiar with, on a Gen 3 at this point, and depending upon what variant engine you got a red connector and a blue connector. And he's gonna tell you every pin is labeled to what it is, and you'll pull out what you don't need, and you'll keep what you do need, and then you'll see what you kind of need to hook up to interface with the Toyota. So I didn't come up with this stuff. You need to go to LT1Swap, his website. You need to watch his videos, and you can either thin out your own harness if you're more on a budget, or you can go online and there's various aftermarket harnesses that you can buy that make it plug and play. I will say this though, that thinning out this GM harness and learning all these different wires and everything like that, it has made it so I have learned exactly how that engine runs and what all the sensors do and where all the wires are. So in the future, troubleshooting, I know exactly everything there is to know about that motor in the future. So I think it was a good lesson. If you aren't the most savvy guy on engines, well, you thin out an engine harness and you're gonna learn in about 2 weekends all you need to know about the GM LS harness. I also did rebuild my motor as well, and I did it just page by page off this book. Never did it before. It was super simple, page by page. So that's about thinning out your harness, rebuilding a motor if you need to, and that. And there's a lot of sources online. Watch YouTube videos. There are a lot of guys from all different backgrounds throwing these Chevy motors into old trucks, old Camaros, old square body, cruiser vehicles. It's easy, it can be done. So moving on from there, I kind of came a list up with great buddy. You saw him in another video helping me do some of the program. Like I wouldn't be here without him as well. And he helped come up with electrical systems to interface. I'm gonna try to, with his permission, put this in the video comments and so you can download it yourself. But I'm basically gonna be going over it as well. So we kind of just broke out all the systems that we needed to, and then just kind of the theory, we kind of just found out what we needed to do in the GM to Toyota schematics. I'm gonna cover what we did here on the schematics page by page. Second thing that you need to do, you need to understand how a relay operates. And there's a lot of YouTube videos on that, because you're gonna need to build, and you're gonna need to wanna write and kind of build your own little schematic for the Toyota of how you did it. You need to understand what 85, 86, 87, and 30 are on the relay and how the relay works. I won't go over all that now. There's plenty of YouTube videos to understand how a relay works, the signal wire via the power of the ground, and we'll cover this as we get into each system. Two other recommendations is do not buy AutoZone wire. That primary wire, it's thick, it's not as high quality. You want to buy TXL wiring. It has a thin insulation. It's pretty much what the OEM engine and vehicle manufacturers use today. So it's thin, it's easier to work with, it's not as bulky. And I would go to wirebarn.com to buy that. And then to buy your relays and relay boxes and your correct OEM styled pins from like Delphi and things of that nature, I would go to Waytech and buy their stuff as well. You don't want to be buying Amazon pins and wiring out on a camping trail and have this, have some junk burn up on you. And then the last piece of advice before we move forward is, I was not able to do this because the vehicle that I purchased already was not a running vehicle, but I could have put a fresh battery in it. And you want to op check everything that you can before you take your vehicle apart. Turn signals, headlights, forward and rear locking differentials, transfer case, did everything in your cluster work, oil gauge, pressure gauge, water gauge, tach, speedo, because when you're trying to get the stuff to work later, you want to know, did it ever work in the first place? So I didn't have that, so I never really knew what was or what was going to work. By the time I got to installing GM motors, I bought a non-running vehicle and went straight into an engine swap. All right, so there's all that. Let's get into it. You need to go on the I Hate Mud website and you need to download the factory service manual for your particular, this is all 80 series. And so you want to print them out in color. And so some of the systems are just a single page, right? But some of the systems you can see here, like engine control, is technically 1, 2, 3, it's 4 pages, and you want to tape those together so that you can follow and trace through the wire diagram. And before you start taking anything apart, go through your list and start to become familiar with just the naming convention and where things might be. So let's get started. We're going to talk about what do you need to make the GM engine run, right? So you need GM, you need battery and ignition power and fuel and ignition. It's pretty simple. All right, so for the GM standalone LT1 website, he's gonna break it out to where that all you need, to call it the 5-wire system, that all you need is battery hot, ignition hot, and then the fuel pump. So how do we get that? Well, battery hot to the computer, that's easy enough. You can just grab a bus bar and a wire and take it to your GM computer. I recommend getting a relay fuse box. Any power that you had going to the, to an item, you want to always have it backed up with a fuse. So that's pretty simple. The battery hot to the GM computer is just off the battery itself, a little bus bar you build, whatever the case may be. And I'll show you what I did in the vehicle. So the next thing that you did is we need ignition hot. All right, so how am I going to get ignition hot or a key signal to the computer? So you can see here that you have your starting and ignition wiring diagram from Toyota. And you can see here that there's several different ones you can see here. If you zoom in, it's IG2, so ignition 2. And you can see here, IG1, ignition 1 is not used. So we have IG2, which has a black and green wire as depicted. And you can see it goes through this I7, which I failed to mention, but you'll want to download not just the wire diagrams, but like in each system, it will have a picture of the connectors that are associated with that page. And it also will show you the splice points and where they will be, ground points and connector points associated with what other system that is, kind of like the next page. And you want to download those as well, so as you're trying to verify that you have not only the right color, but you found the right connector, and you want to make sure that then it's also in the right pin as appropriate. So you want to download those as well. So going back to ignition, you'll find this black-green wire. You'll see that it goes in the engine bay to the ignition coil. So here's a great Toyota source in the engine bay that I can use for my key ignition source. So that gets power through the entire ignition cycle. But you also want to make sure that it maintains power when you not just go from kind of like the ACC, like the on position, but through the crank spring-loaded position. And I verified that just with a meter as someone was turning the key. So this power will stay hot the entire time through not only ignition on, but also through the crank detent. So what I use this as is a Toyota signal wire to now get ignition power to my GM system. So there were several things that we needed to power, and I used that ignition wire to control a relay. All right, so you can see here that and it has already had the Toyota fuse on it. So if you look, this is already going to come through here to the Toyota fuse. All right, so it's already has a fuse. Black-green wire from the ignition coil. I used it to control the relay. The other side of the relay, I had a chassis ground, and then from a battery bus, hot bus bar that I built, I then had current going out to the PCM ignition hot, the injectors, the coils, the mass airflow sensor, and the heated O2 sensors. Originally, I also had it powering my Dakota digital boxes, but I changed my mind on that, and I'll show you where I get that before. So I used that signal wire from the Toyota ignition to control a relay to power these GM functions. The PCM ignition required signal, power to the ejectors, coils, MAF, and heated O2. I had it go to one fuse, and then I just daisy changed those 3 fuses, and then each item I had fused out. Okay? So that covers how did the GM get battery hot and ignition hot, and how we actually powered the motor. The last thing that we need is fuel for the motor to run, right? So there's a lot of talk on the forums about using the Toyota Land Cruiser fuel pump, which is plenty adequate for a standard GM truck motor. If you're going real high horsepower, a Corvette or some turbo or blown motor, and you put aftermarket fuel injectors or whatnot in your motor, if you're doing all that, you probably already know all this already. But let's just say you just took your stock 5.3, your stock 6.0, maybe you put a slight cam in it, maybe a little tune, but you pretty much are running still stock injectors and a stock fuel rail. You're not going to overdraw your fuel system. You could put the Toyota Super Pump in it or a different aftermarket fuel pump, but the stock fuel pump will work just fine. I also use the stock fuel lines. Some guys will run aftermarket fuel lines to get it away from heat and other items. Some guys do, some guys don't. I haven't yet. I'll cross that bridge when I get there. But so how did I get power from the GM computer, which will control a fuel pump? It won't power it, but it will control it, to the Toyota fuel pump. So you'll notice that the Toyota fuel pump has 3 components, 4 counting the motor. It has an EFI main relay, which is in the engine bay, okay? So EFI main relay. You have your circuit opening relay, which is in the driver left-hand kick panel. You have a fuel pump relay, which is in the, I believe, the kick panel as well. And then you have this fuel resistor. It's kind of a complicated system. You have to remember, but this was early fuel injection. And what Toyota would do is they would run this fuel pump at different RPMs for different loads at different times. It's kind of not required for a GM motor. We're just going to run that fuel pump at full power all the time when the engine's running. That fuel pump doesn't care if it's running at half power through this fuel resistor or not. It's just a little electric motor. It's either spinning or it's not. We'll take all the fuel that it provides. It will last another decade. You're concerned about it, put a new one in there. It'll last you another decade too. All right, so what I wanted to do was we didn't need the circuit opening relay. We don't need this fuel pump relay. We don't need this resistor. So if you track all that down to the fuel pump, which is, let me see where it is on this diagram. The fuel pump goes to, I think the fuel pump's actually not pictured on this actual diagram. Oh yeah, it's right here. Here's the little fuel pump. So how are we gonna get power to this wire? Okay, right here. And I don't want any of this stuff. So in the engine bay, and again, I'm gonna show you this, you can find this yellow and red wire, all right? And what we're gonna do is we're gonna bypass all this nonsense that we don't need for GM, and we're gonna find this red-black wire. And we're gonna take this wire, and we're gonna splice it together, which is now gonna take power to this wire, through the splice joint, to the fuel pump. But how do we get power to here? If you trace back the yellow and red across all the pages, all right, yellow and red wire, it traces back right back here to the EFI main relay. So we're using the Toyota relay, which already carried 100% of the current for the fuel pump, so we're not over or undersizing any of the wiring or the componentry. And so now this relay, you can see, is controlled. It already was hardwired to chassis ground. It got a signal, a power signal from, if you look here, the engine control module, right? So why don't we just hook this wire up to our PCM, our engine control module? And luckily enough, the GM PCM for fuel pump on or off puts out a 12-volt signal. It's exactly what we need. So you take this wire right here, you'll splice this wire to your GM PCM fuel out, which again, you'll get from, you'll find that on the LT1 swap, which wire it is. I'm not gonna sit here and look through that again right now. All right, and so now the GM PCM will control this relay to turn the fuel pump on when we need it. And that is how I did the Toyota fuel pump for the GM. All right, so that's the fuel pump. Let's talk about how we got a crank signal. All right, let me look at our crank signal here. So two systems kind of involved in how you get the actual crank signal to the starter on the engine. You need the neutral safety switch, so you want to make sure that the vehicle is either in neutral or in park. And that ground, which is going to be provided, which would have been provided by your Toyota transmission, is now you need to find how you're going to get that ground. Most guys are using the Dakota Digital control boxes for that, and that's what I'm using as well. So if you come look at this relay right, or this part here, what I'm doing is I'm taking the Toyota start signal wire, and I'm putting that to the power control side on a relay. For the ground, I'm using the Dakota Digital neutral safety switch to provide a ground. So I need the power and the ground to control this relay. Then I have power from the bus bar, which will go out and it will go to the crank solenoid on the GM motor. So what does that look like? It's the crank signal wire, which if you go back to gotta find which schematic it was. Of course, I don't think I have it. Oh, here it is. Sitting right here. They call it the start wire. So it's the black-white wire. You'll notice that it goes through connection IH1. IH1 is about going to be your favorite connector in this whole thing, in the whole swap. You'll see that it went through here. It went through the Toyota neutral safety switch, which was on the transmission. It then went to the starter solenoid. Starter then has the battery connection as well. Solenoid starts the starter. So we needed this signal, right? You'll notice that Toyota, kind of like a more of an old school method, it used heavy current through the transmission neutral safety switch, just the transmission position switch, which most modern vehicles don't do it that way. They'll use relays to control that kind of power. So you, in theory, you could have connected this to your GM starter. You would just need to look at this amp load on the start solenoid. You could have connected that wire to that wire. And it probably would have worked fine. It had a fuse already on it through here. And you could have connected this to, which is the purple wire on your GM harness. How I did it though, is I used a relay to do it because you wanted the safety feature of the vehicle being in park or neutral safety switch. Because if you just connected this wire to your purple wire on the GM, you'd be bypassing the safety feature. So again, you find the black-white wire, use it as your signal to control your relay. Relay gets the ground from the Dakota Digital box. Power from a bus bar goes out to the crank solenoid, which is the purple wire, I believe it was purple wire on the GM harness. So there you go. So far we've covered GM battery and ignition hot, the PCM. We've covered how we did fuel, how we did ignition, how we did the crank and the neutral safety switch. Let's talk about how to get the tach to work. All right, so the tach is a little more tricky. I had some problems getting mine to work. I'll cover that in a moment. So I used the Dakota Digital SGI 100 BT for Bluetooth signal converter. So I was able to use the tach output signal from the GM computer, which again, I'm not going to look through this again to remember which one it was, but I used the tach signal output from the GM computer, and I put that into my Dakota Digital box. And where I tied in at for how we got the tach signal in is you got to find this black wire, which you can see here went to the igniter. All right, but if we trace out a little bit also where this wire goes to, which is on the igniter, you'll see there's a little more to the story of where that igniter is. And that's why I was saying you got to print these out, you've got to study it, and you'll start to become more familiar with it. So if we find the igniter on the engine control diagram from here, it was pin 4 on connector I2 on the igniter. So here we go I2, we're on the igniter. Well, here's pin 4. You'll notice that while there's more wires in that connector. And you'll see that it also has a splice. But you'll notice here on this one, it doesn't show that it's spliced. So there's just more information to it. You'll see here, there's another splice point, and you can see it goes to the tach and the combination meter, the cluster. But there's also more information to it as well on another diagram, which is we're going to read to, if I find it here real quick. So if you read it, this black wire, it goes down and around, again, to our favorite connector, IH1, passenger glove box, pin number 4. And so you're going to take your GM PCM output and you're going to splice it onto this wire. And that's how you'll get that, a correction. You'll take the output of the Dakota digital box and splice it onto that wire. The input from the GM PCM goes to the input of the Dakota digital box. So that's that wire that you need. You also know that if you follow it down and around, it goes to that test junction box that was in the GM or in the Toyota harness. I've already removed all this sort of stuff, so you can kind of find this wire here at that test port in the engine bay, or you can grab it here inside the glove box at IH1. I used this part there. So that was the tach. There's a little more involved to getting the tach working. You'll notice on 2 other videos of a guy, I Do Cars, where he talked about how he had to bypass a resistor on the back of his tach module. I also had to do that. I could not get it to work otherwise. I was on the phone with the Dakota Digital Tech Support. We tried a lot of different settings. Another video, when we go out to the vehicle, I'll show you what those settings and whatnot were. Some guys get it to work, some guys don't. I think the difference is the Dakota Digital boxes have changed through the years. That's not always represented. You don't always know that. They also claim that Toyota has changed that cluster through the years, which doesn't necessarily line up with model years. There could just be slight electronic changes to the background of that cluster. So there could be changes with that as well. So you got to be patient with that, and you've got to be willing to try several different things to get the tach to work. I got mine to work. It took me 2 days, 2 days to get mine sorted out with tech support and help and trying the jumper, not the jumper, and other issues that I will show you as well. But that's the wire that you want for your tach input. Just go from the out of the Dakota Digital box and then the PCM. All right, let's talk oil pressure. Oil pressure is no issue. You'll just take the harness that you have from the Toyota, and you're just gonna extend those wires to reach to the back of the oil port on the GM motor. The GM oil pressure transducer, the computer does not care what the oil pressure is. It doesn't see it. It was only used for indication in the GM trucks as well. So I used the port that is on the back of the motor behind the main intake. You also could use it, some guys will splice into where the oil filter goes. I don't think that's necessary. I just use this port right here since the GM computer does not need to see the oil pressure input. And so you'll just extend this wire and then hook it up. You got to be very careful, because if you ground the sender wire, you'll bend and break your gauge. So be very careful with that. That kind of goes back to make sure you op check everything in your vehicle before you take it apart, so you kind of know what does and what doesn't work as well. So that's oil pressure, pretty easy. Let's talk water temperature gauge. Again, super simple. Now the GM PCM does need to know the water temp, so you're going to want to leave the GM water temp sensor connected. There's going to be another port in the opposite head that you can take. I know Wits Ends sells a Toyota water temp probe that he has rethreaded to fit the head of a GM motor. A lot of speculation about what's in and getting parts out of there right now, but you also could just buy a new one and probably take it to your local machine shop and have somebody rethread that for you as well. So not impossible to get done in town either. And then you just simply use the Toyota wire and the Toyota water temp probe, and it works good as new. And I'll show you that in my vehicle as well. So let's see, we did oil, we did tack, we did water temp. The speedometer, that's going to be untouched off your transfer box. Again, make sure it works beforehand. You won't be messing with the wire harness that goes down into the transfer case where the speedometer is. You won't be messing with any of that wiring. So that goes untouched. Don't touch it. So that's about it. The fuel level goes untouched, and the amperage kind of goes untouched as well. One thing that I will talk about is going to be this charge light that I have about figured out, but I'm not 100% on it yet, so got a little more to follow on that. So if you look at the charge light, this charge light goes to the charge fuse, and this light via these diodes, the light always has a power to it, right? And so this power is going to go through here to the charge fuse. But if it gets a ground on this side, this light is illuminated. So this wire can either have a ground or power on it, and that's going to be when or when not the Toyota alternator was working, and you'd get that red charge light via these diodes. So, and where this wire comes down to is this charging light. So you can see it has a power through a diode, and you're like, well, that's weird. There's another fuse here too, but that's because of this diode. When the Toyota alternator is not running, this has a negative or a ground on it, and you would get the light. So when you first turn on your key, the engine's not running, you would have your little red light on above your voltmeter. So you start the car, it starts putting out power. It won't go through the diode, but it loses its ground, and now the charge light goes out. So someone just posted a great link. So you got to find the L terminal on the GM alternator. There's going to be ignition L, S, and F, which I'll show you marked on the GM alternator. And so we should be able to take this wire, splice, and put it into the wire on the GM alternator and get that system working for us as well. So no big deal there on how that's going to work. All right, so let's talk about how do you get your parking lights to work. Park, reverse, neutral, drive, to, low, etc. Again, your two favorite connectors, IH1, IH2, behind the passenger glove box, which one went to the engine control module, and then one is just a body panel connector. So you can find here that you got your park, reverse, neutral, drive, to, and low lights. And you can find these associated colors, red light blue, red black, red, etc. at IH2, IH1, IH2, IH2, etc., etc. And you'll find that a lot of these same wires go to the same connector, which are going to work for your front and rear and center differential as well. So these wires are kind of going to be joined up together. So you'll depin these, and you'll find these out of the IH2, which was an engine connector, engine computer connector. You'll depin all these out. Now, since my vehicle wasn't running, what I did was I used a jumper wire, and I jumped all these to power, and I was able to verify that these lights did or did not work as I went to go move forward to hook up my Dakota Digital box. Of course, my drive light was burned out, as many of y'all's are, so I'm going to replace that since I already had my cluster out. But now I know that, in theory, that when I get my Dakota Digital box set up and I output on these wires, I'll get these lights to illuminate. So pretty simple with that. I haven't hooked up my Dakota Digital box for the parking lights or my neutral safety switch just yet. I have been risky, and I've just been putting the crank switch to chassis ground. It's not how I'm going to end up with the vehicle for overall safety, but just kind of where I'm at right now for testing and troubleshooting. that's what I've done thus far. And so that's the next thing that I've got to hook up. Let's see here. One of the last things that I have to figure out is your TCC, torque converter lockup signal. So what we got to do is you got to find your brake lights. You got to, I don't know if I have that schematic here with me for the tail lights and the tail light switch. But that's just, you got to pull off the brake light switch, which is underneath the brake pedal. Tie that into the torque converter wire on the GM PCM, and that's how you'll get your torque converter TCC signal to work. There's 4 pins or 4 wires on that. 2 go to the brake lights, 2 go to the cruise control system. One of those is going to work for you. You'll just have to splice off to that and run that to your GM PCM for your torque converter brake pedal indication there. Let me see. That is, I think, kind of covers everything on the swap in theory. Now, I know seeing it in the vehicle is another story, and we'll do that in the next video. But again, download the factory service manual, print these out, tape associated pages together, and just begin to gain familiarity with it. Write out your notes, write out your plan, which is for your model. Get the pinout from LT1. Even if you buy a separate harness, it's still gonna be nice to know what the pinout goes to the actual GM PCM, and start making your tie-ins. So that's the theory of it. I know seeing it is different, but that is the theory of it all. Get it printed out, and that's how you can get it done.
Links in the description.
I'll get the, try to get that Word document in there. Ask me some questions on the forum. But again, I've never done this before. A lot of help from a lot of people, but just take your time and you'll get it figured out. Thanks.